Hello and welcome to the Extended Greg YouTube channel. I'm Greg and today we're going to be building a Raspberry Pi video encoder. You could use this with OBS or we're also going to be streaming it to another Pi. But before we get into it, be sure to subscribe and smash that like button. But stay tuned, we're about to have a lot of fun. So let's get right into it. Okay, so first thing that we have is we have a Raspberry Pi. This is a Raspberry Pi 5 and what it is pretty much a stock Pi. I do have an NVMe in here just for random reasons. That's just what I had. But there's nothing special about it. Now, the big thing about the Pi 5 is that it actually doesn't have any kind of hardware encoding. Now, versions 1 through 4 all had a hardware encoding where they could actually do it through the GPU. And we'll go through that in a little bit. But pretty much, this is going to just use the CPU, but it's perfectly fine because the CPU is fast enough for 1080p video. So it's not actually an issue. And what I have for the video encoder, and actually this is what I recommend, is some kind of cheap, this one's like 30 bucks on Amazon or something like that. I don't specifically endorse this one. I've tried a couple, including the ones down to like $5. But the key thing is to have one that actually outputs MJPEG or motion JPEG. And the reason why that's important is because it significantly reduces the bandwidth involved to actually get the encoded signal into the Pi. And that reduces overhead significantly, and then you don't suffer as many performance issues. So over here, what we're actually going to be streaming to is OBS itself. And I'm just going to slide this out of the way. All right, is OBS itself. So inside of OBS, we're going to open this up, assuming I can put this on the right computer. We're going to open up OBS, and I already have this defined. And it's just adding a source, and you would add a media source. And add a new source, but I'll show you how to set it up really quick. So in here, normally local file is checked by default. So we're going to not check that. And that'll allow us to use a network source. So for us, we're going to be using SRT for this. So I already have the encoder set up. It's in Linux. I'll show you that code in a second because we're going to start that after we get this started. So we're going to do the URL srt://. Then we're going to do the IP address of our Raspberry Pi and the port number that we define. And then we're going to do $mode = caller. Now, SRT operates over MPEG-TS, so for our input format, we're going to put MPEG-TS. It's going to determine all of our codecs that we're using automatically. Now, we do need to just specify a few things in order to keep the delay kind of minimal. So in this particular case, I did FFflags = ignore DTS. That just ignores pretty much some timing information that rides along with the stream that isn't really important in this particular case. And then the key ones that keep it low delay is probe size = 32, which is the minimum. Analyze duration as 0, so it's not going to sit there and wait and analyze, which will increase the amount of buffering that it does. And then max delay = 0, which will keep it as fast as possible. So pretty much as soon as it decodes it, it will actually put it out onto the display. And then we keep our network buffering a little low. You can try and put it at 0, but I found that between 0 and 1 with these options, or even pretty much any value, it won't significantly increase the amount of actual buffering that occurs. That's the allocation of the size of the buffer itself. And then for reconnect delay, etc., 2 seconds. You could choose or not to do hardware decoding when available. In this particular case, I'm not, but we can, and we'll do that in a second. I'll show you the difference. It doesn't really make a difference. All right, so right now it hasn't started, but we haven't started our encoder yet. So let's go ahead and switch over to our encoder. And this is the Raspberry Pi 5 that I just showed you. And right now it's running Raspberry Pi OS. And nothing special about it, but I chose Raspberry Pi OS just because it has a little bit of a performance gain, just because of some optimizations that Raspberry Pi has done, versus Alpine Linux, which also runs just as well, but is a little more difficult to get going. But we are going to run Alpine Linux on the Raspberry Pi 4 when I show you the hardware encoding. And again, you can also do this on Raspberry Pi OS on the Pi 4 with hardware encoding. It makes no difference. So I just happen to choose these just based on trying to show a little swath of an example. So I'm just going to run it first, and let's look at it, and then we'll look at the code. So right here, we have it running. We see that it's encoding about 30 frames a second. This number down on the side here, and actually I should have set up my telestrator for this, but we see that it's running 30 frames a second, and the speed is about 1. And that's really what you want it to be. Because this is a live source, we want it to be encoding as close to 1 as possible. Otherwise, it's going to potentially underrun or overrun the buffer. So if we switch back over to the computer where we have our receiver, we now see that the video is present. Right? So I can tap over here. We see the motion is good, everything else like that. For whatever reason, on the Pi 5, the audio hasn't been coming through on the SRTs. It has been on the Pi 4. I'm not entirely sure what the cause of that is, but I'll show you another way in a second to be able to decode it using the Pi 4 to be able to actually get that audio through. And in some ways that can actually be better. So we see it running, we see the motion is good, we see the video quality is good. You know, this happens to be another machine. This is not the actual instance of OBS that I'm using to encode this stream. But going through and taking a look at the code. All right, so I'm going to stop this. I'm just going to hit Control-C, and let's go ahead and take a look at the code itself. So we see the same thing. So FFmpeg is actually doing the encoding. We're doing FF flags, ignore DTS, again, just to stop any kind of issues with pretty much timestamps. Flags, we're putting global header. That has to do with just making sure that it starts quickly. We don't want it to wait, and you'll see a lot of these flags and a lot of these options that we select in the encoding is really to try and minimize delay. Now, on the second line here, this is where I actually have the input defined, and this is only the video. So we're using video for Linux as the format, and that's to interface with physical I/O devices. Then we have our input format, and we define it as motion JPEG, MJPEG, and we set our video size here. In this case, I'm doing 1920 by 1080, and we define the frame rate as 30. So that matches my stream settings that I'm using for my output, but it also configures the input device so it's using those settings natively, so it's not having to convert it on the fly. The motion JPEG encoding is actually done in hardware on the input device. So we don't have to worry about that, and that removes a lot of overhead from our processor. And by setting the input size, everything else like that, it makes it so we're not having to do a downstream conversion. And the device itself is /dev/video0. Now, pretty much it doesn't require any additional drivers or anything else like that, but as soon as we did plug it in, I'll show you really quickly. The way that we found that is ls/dev/video star. And you see here there's a number of devices that actually show up, but that very first option is video 0. That is the physical device. The other things are actually registers for doing the hardware encoding, and if you did try and do that on the Pi 5, it would say it couldn't find the hardware to be able to do that. But if you unplugged your capture device, the video 0 would actually go away. So important to check that. If you have multiple capture devices, you know, more of those will show up. So back in the file, the third line that we have here is actually our ALSA device, and ALSA is for audio. And we have it defined as a real-time device because that's going to set our clock, just because audio tends to have a much better clock than video, and it does keep it a bit more consistent and also prevents buffer overruns. And then for our input device itself, we have it defined as hardware card 1 device input 0. So the way that I got that, showing that as well, is I did a record, which is part of ALSA utils, which is how we actually installed the driver for that, -L. And here we see there's only one device connected, which happens to be the capture device. And we see it shows up as card 1, device 0. So that line right below the stars, card 1, device 0, and that's actually what's doing the capturing, and that's where we got these numbers right here. This fourth line is where we have our codec specifications for the encoding. So in this case, we're using a software encoder, which is libx264, so it's H.264 encoded. We're going to stream at 6 megabits per second, or 6,000 kilobits per second, give or take. And that's pretty much going to be our video specification. For audio, we're going to do MP3, but another option would be AAC, and we're going to use a bitrate of 128 kilobits per second. And here, this is how we define our sync. So for our FPS mode, we're going to choose constant frame rate, or CFR, and that's going to pretty much make sure that we're always running at 30 frames per second. So if it finds that the input source has duplicate frames, things like that, by timestamp, it will drop them or add them in order to make sure that the output is always 30 frames per second. Now, for the specifications for the encoder, we do a little bit of tweaking in order to be, for the video codec in particular, in order to make it as real-time as possible. So we change our pixel format because we need to have it as YUV 420p in order to be compatible with libx264. Otherwise, we'll get an error. So we just set that here. -G is our group of frames specification. So how often is it going to send a full frame? And that's to prevent, like, so if there's network interference or something like that that causes lost packets, this will resync it so that way it clears up the image, and then the incremental frames or iframes that are sent in between are pretty much, or intermediate frames, are going to be building on a known good image. Otherwise, it will start looking blocky and the image will just fall apart. So we have that sent every 2 seconds in this case, because we're running 30 frames per second. For preset, we're using ultrafast, so we're using the lowest complexity encoding that we can. And then we're tuning it for 0 latency. So that way we're not having to deal with, any kind of additional delay induced because of the codec that we're using. We're also resetting timestamps, so that way it starts from 0. This is useful because if you were to capture this stream, for example, it would start counting from 0 opposed to showing numbers. And it also makes sure that our actual stats in FFmpeg, which are based on those timestamps, are accurate. And then, in order to make sure that it starts quickly as fast as possible, we're adding -MOV flags. We're doing fast start. And that puts some values at the beginning of the file, of the beginning of the stream, in order to make it start as quickly as possible instead of putting them at the end or in the middle. And then we do omit video PES length. I'm not going to explain what this is in particular, but pretty much it's just not going to attach a length value because it's a live source. So it could be any amount of time. So it's not going to say it's this long. And then on this last line here is where we have our output settings. So we have it set for format of MPEG TS. And then we define SRT : //. We put the IP address of our actual output network adapter on this particular Pi. We put the port value that we want, and then we do mode equals listener. And that way it'll wait for a connection from the caller that we defined in OBS in order to actually start running. And that's it. And in this case, I don't have it set to automatically recover. We could add it in a while loop, and you'll see in some of the other examples that I did that. But we have it set to go here. So let's exit out of that, and let's go ahead and run it again. And we'll see it start streaming. And this is an occasional bug that comes up where it goes 1 frame a second. We just have to restart it. There we go. And that's more to do with my input device. So if we go back over to the computer and look at OBS again, we see it is running. We see I can give it a few taps, things like that. We see the motion is good. The image quality is good, you know, and it's all working. So if I actually look at it, you can see the green screen there, but it is working as expected. So let's go ahead and we can actually close this out. So we're gonna close this out because only one connection can happen at a time using SRT. I'll show you in a second as well when we switch over to the Pi 4 how to do multicast streaming using hardware, which will allow for multiple devices to connect simultaneously. But OBS does have a problem with that. But if you're connecting to another Pi, that's no issue at all. So now that we have this running, we'll switch back over to our encoder. I'll show you it exited on its own because obviously we closed out our decoder. They're a match set, so they are aware of one another. So that's very important because if it does fail, you have to restart it on both sides. And in the case of OBS, we have it set to reconnect, but unless we put it in a while loop to make it automatically restart FFmpeg, it's just going to crash out back to the command line and we'll have to restart it manually. So let's go ahead and start this again here, and we're going to connect up a different decoder. And you see how it just kind of waits here. But let's go to a Raspberry Pi 4. And this one is doing a decoder script. Now, this one, I know the text is going to be really small just because we're not actually going to look at anything on here as far as text is concerned. But what we are going to do is we're going to run a little decoder script that I wrote. And let's see if it actually went or if it decided to crash out. We just got to restart it. In this case, I have the decoder on a loop. And we see it did that one frame of thing again. There we go. So I'm going to switch back over to this over here. All right, now we see our video. And it's full screen, right? And this is outputting full screen from the Pi. But here's the wonderful thing. So I'm going to mute my mic here really quick. Right, so this does have audio. So now when I'm talking, you can hear what I'm saying. And it has a bit of an echo just because I got speakers so I can hear it as well. But this is actually doing everything that we would need to be able to broadcast. We see it is just coming out of, well, it's coming out of the Pi HDMI. So there it is right there in the back, right here. And it's just outputting it regularly. Ignore that ribbon cable. That was me trying to use the CSI input for the actual camera. So let me switch back over to my So pretty much that's going point to point, and it's very easy to do. It's very robust. You know, it's something where if you set it both sides, you now have a hardware appliance that you can just kind of tote around. And if you make it so it starts up automatically, it makes it a lot easier to be able to start streaming. So now that we've got that, let's actually go ahead and stop the encoder here. And we're going to shut it down and reconnect a Raspberry Pi 4. And if you want, while that's booting up, I'm just going to reconnect this here. So watch. I'll let you watch as I reconnect this. So I'm going to shut this down gracefully because it's not embedded. I don't have the memory thing turned on. So it is shut down. Get this all unplugged, and then I have this Raspberry Pi 4 here. Again, nothing special about it. It does happen to be 8 gig, but nothing about that is particularly critical. So we'll go ahead and plug this in. And actually, I'm going to hold off on plugging in the USB peripherals just because I know it has issues booting. And we'll switch back over to KVM. Make sure it actually starts booting up. There we go. For some reason, I have to plug in my keyboard after it finishes booting, otherwise it doesn't boot up on the Pi 4. It has no problem on the Pi 5, or excuse me, on the Pi 3 and below, but for some reason it doesn't like whatever my mouse and keyboard setup is, which is wireless in this case. So we're all booted up, so let me go ahead and plug in the keyboard, and I'm going to plug in our video capture device. And let me move this out of the way once again. So this is Alpine Linux, and I'm just going to log in. And I have a couple of different examples here. So first one I'll show you is the SRT example. So we'll do test 5. And I do need to go back over to the decoder, and I need to change an IP address. So I'm just going to go in here. I'm going to quickly VI test 2. And I will make these scripts available. You're not going to be able to see this, so I'll show you this in a second. And just change this IP address. And I think that was the IP address it gave it. I should actually confirm that. So I set it to IP address 35.100. Oh, it's doing that thing again. There we go. And in this case, it's only running 24 frames per second. This is using the software encoder again. Okay, just to show apples to apples, and then we're going to show the hardware-based encoder. We do see that there's some errors coming up in terms of underrun, things like that. Not too great. But if we switch back over to our decoder, we can see it exists, but it's a little bit choppy, right? So it's not quite keeping up with what we want it to do. So going back over to our encoder, let's go ahead and change that. So I'm going to exit out of that. I'm going to do VI test 5. And I've broken all of this stuff out here to variables just to make everything a little bit easier. And included some notes to be able to tell you how to get some of these values. So instead of doing libx264, what I'm going to do is put h264 underscore v4l2 m2m. And that is a hardware encoder. And it's going to use the GPU to actually do the encoding of the video itself. And just to keep everything apples to apples, I'm going to set this to 128, which is what we had on the other example. Everything else here is pretty much the same kind of setup. So not a lot different here. It doesn't require any special flags. It does require some special packages for Raspberry Pi to be installed, specifically so it can access those hardware registers for the encoding. But when I go into run it now, we see how it's running at full frame rate. And maybe even a little bit too fast, but it's running at full frame rate. So now when we go over here, we see it's running fully. And if I go and I mute my mic, check 1 2. Check 1 2. So we see that it's running as expected. So pretty much it's doing what we expect it to do. We're using hardware encoding of the Raspberry Pi to be able to enhance its performance since the CPU wouldn't be able to keep up on its own. So going back over to look at another example. So on the encoder itself, we'll exit out of that really quick. I have a few other examples available. So the first one is test 1. And what this is going to do is it's just going to output it to the local screen. So this is a good way to be able to test your camera. It's just going to take the input and output it as HDMI. you can actually use this for a number of devices, like the Pi camera that plugs in through the CSI connection. That will show up as the Video Zero device as well. And you can use this same command line to be able to have it output through to the local display in full screen. Not with audio in this case, so there's no audio in this example. So if we run this, this is just being directly output, and this is the fastest latency that you will ever get. So we can see here, it is pretty darn close, so it is something where there's quite a bit of horsepower. The latency is not that bad, for itself, but something else you might notice is that occasionally some text pops up. In some of the other examples, like example 5 and also the decoder, I actually have it turning off the background console to make sure that it's not going to be interrupting it, because this is just running from the command line. If I hit Control-C, you see that really it's just on top of it. There's no set display, nothing else like that. So in some of the other examples, I have it also doing that. Now, let's say we wanted to do something a little more advanced, right? So if we go into test 2, what this is going to do is it's going to take our motion JPEG, and then it's just going to do a regular MPEG TS stream as a multicast stream. So this allows you to do point to multipoint, and it also decouples your encoder and your decoder, so if your decoder crashes, your encoder's still going to just keep running. It doesn't care whether there's anything there to decode it or not. And we're going to do the same kind of thing here. I'm just going to switch this over to 128. And we're also using the same hardware encoder that we were using a second ago, which is H.264V4L2M2M. And M2M stands for memory to memory. So it's just a little bit faster. And we can also scale it as well. So for our case, we're running a 720 screen. This is going to do a frame buffer scale, so that way we're not cutting off our video. And that does take up a little bit of extra process, things like that. And also the command line itself is a bit different, because what we're doing is we're going to output the multicast, we're going to encode it with hardware, and then we're also going to output it to the frame buffer in order to be able to see a preview of what we're sending. And this is really a little bit beyond the limit of what the Raspberry Pi 4 can do. But it still kind of works. Kind of. So let's go ahead and run that. Whoop, let's not mess up our file and go ahead and run it. If I could type. There we go. All right, we'll give it a second to settle down. Kind of works. Kind of. I think it may have crashed. Let's see. Let's try it again. And let's try and get our decoder working as well. So I'm going to switch back over here. I already have one that's preset for actually doing our capture on this. So I'll escape out of this, and we're just going to do test 1. Test 1 is pretty much the same thing, but the address is already preset to our multicast. See if we're still encoding here. If it falls over, I'll show you that's why test 3 exists. Yeah, I don't think it made it. Whoop. Right, so it's not really keeping up. We switch back over to our decoder really quick. Not really making it either. Let's make sure that this is actually set correctly. Right, we see our multicast address here. We also see that it is also scaling it for our frame buffer as well. In this particular case, I actually don't think that we need it. I realize I did put in an adapter that makes it 1080. Here we see the cursor blink. You're not going to be able to see this. This is going to be too small if you're looking at it on a phone. But if you're looking at it at a 90-inch TV, it's going to look fine. Alright, so it doesn't look like it's going to want to run, and it keeps crashing. So it's a little too much. So we need to scale it back a little bit. So I'm going to exit out of here, and let's take a look at test 3. Test 3 is pretty much the same thing, but we get rid of the preview, because the preview is taking a lot of effort. And big thing about the preview is that it's doing uncompressed video to the frame buffer. So it is a very bandwidth intensive. It's not necessarily, I would say processing intensive, but we are doing a scaling function as well, and that's certainly not helping. But it's nicer because then we get to look at stats. So we're doing the same thing here. I'm just going to conform the audio once again. We're still using our hardware encoding, and we're still outputting to FFmpeg TS on a multicast stream. Everything else is pretty much like we did before. So here we're running. We see it's running at 30 frames a second. Very steady. It's well within the capability of what the hardware can perform, just like it did before. We can go back over to our KVM, or excuse me, to our decoder. See if we can capture it. See if it wants to cooperate first. Let me just double check, make sure. Oh, I may have some things here that aren't supposed to be here. It took a long time. It's actually been a couple weeks where I've been messing around with this, trying to get a good sample of exactly what kind of things worked, what kind of things didn't, to see what was most reliable and what was the best option for actually trying to do any of this. So here's something that we can do. Just because we don't have any console output, anything else like that, I actually put in a flag to be able to debug this. That'll give us some information on exactly what's going on. So here we see it's running. It doesn't like what it's seeing. So what we're going to do is we're going to stop the encoder side. Right? So I'm going to close out of that. I'm going to go back over here. I'm going to have it so we restart this. Come back over here. So that was our decoder. Now I'm coming back over to the encoder. I'm going to start this. This is going to run. Go back over to our decoder, and let's see what we got. Perfect. No, it's not perfect, but it's doing things. And we see it's actually going overrunning. And let's see. What did I put in here that made this do that? And I didn't put that before either. Okay. Perfect. Okay, let's do that exercise once more where we stop this one, start the other one. Again, without them being synchronized, it does make it a little bit difficult to be able to make sure that everything is staying in sync. Also, there are some other flags to be able to optimize it, but it made things really long. So, better? I don't know. And again, we're still debugging it, so we're going to see a lot of text breaking up the video on our screen, but at least we'll know that it's working. Right, so we see we're running about the right frame rate. We come back over here. It is running, but it's not doing it. It still says frame 1. And then we're getting audio overruns. So it's not playing along. Fair enough. And I just want to go back over here and make sure that our encoder is actually set correctly and I didn't add a bunch of weird things into here. Yeah, this does mapping as well for 0V to take it from the first stream, audio from the second stream. Then our codec, audio, video. Again, CFR for our FPS mode. Everything else, I do have this, which shouldn't be here. And then everything else is the same. Cool, just checking. The CFR is conflicting with also, well, I don't know that that's the issue, but the CFR, or the constant quality, constant rate factor, CRF, is related to the bit rate. So the higher the CRF, the higher the bit rate, but because we're specifying the bit rate explicitly, those two options conflict with each other. So that looks about right. So it's just filling out a bunch of things. Let me make sure. FFmpeg TS, Everything else should be good. Cool. Go back over here to our decoder. It's going to say it doesn't like anything. It hates the world. Error submitting packet to the decoder. Totally fine. Let's restart this. Make sure that this restarts. And see if it runs. Otherwise, we'll move on. We'll do the SRT example, which is apples to apples with what we had before. Go back into OBS after that. So it still doesn't want to play nice. It's doing audio. So I see it doing audio. We can actually listen to it. Oh, that sounds amazing. Sounds amazing. It agrees. So it's getting a little hung up, so it's not able to synchronize everything. So I have a feeling there's a timestamp issue, because sometimes it will do that when it can't, when one of the things is actually specified for pretty much synchronizing to it, which in this case is the audio by default. It will, if the timestamps on the video and the audio do not match, it won't display one of them or it won't play the audio. So that's a common problem when you're doing capturing in Linux and it's not an aggregate thing like a Blackmagic device where it handles it in a different way, like a Decoding card. So just something to keep in mind. Always a lot of fun. So we're going to go back over to example 2 on this one, but we're going to do a quick edit on it just so we can see that as well. So instead of having it connect over to our previous one, oh, we did do that. We did do that example. All right, yeah, so you saw the SRT already. So going back over to OBS, so let's go over to our encoder. This is, again, still the Pi 4. We're going to set it to do our other example. Go into OBS. In this case, it is test 5. So it's going to wait. Again, this one is awaiting our fun and exciting. Good, it has the right thing. I put CRF in here as well, which is complaining about it. But other than that, it is pretty much the same exact thing. Okay, so now we're going to go over to OBS. So we have nothing running on the other decoder, because again, we can only have one at a time. We're going to have to change the IP address over here as well. And let's see if it actually connects. So back over to our encoder. This should automatically reconnect. It's doing the 1 frame a second thing. There we go. Back over to our OBS instance. And we see using the Raspberry Pi 4 using a hardware encoding, we're able to get a stream out of it and into OBS. Now, the audio thing obviously is kind of annoying. I'll put it this way, it's been inconsistent, so there are other ways to do it. And granted, it is something where, is this more valuable than using like one of those dedicated telecom style point-to-point systems to be able to do the same thing? Maybe. If you're doing something where you want to be able to have it just be like power on and go and be available all the time. So like, let's say you have a camera, like one of those Earth cams. You know, this is a good thing to be able to use this kind of thing for. You could actually have the camera built into the Raspberry Pi, have your Earth camera shooting some kind of wildlife like a stream or something, and have it automatically come back and display it on your wall, or bring it into OBS to be able to create a stream that other people can enjoy. So there's a lot of options for it. And I see Jacob Christ, are you streaming someplace other than YouTube? Asking because I don't seem to be seeing the question you are answering. Oh, I didn't. No, I'm not answering a question. I'm answering my own questions. So, of all things, yeah. I'll put it this way. There's not a lot of action in chat. So it is just me streaming on this, and I'm kind of talking to myself if you actually saw it. But I appreciate you asking that question. Totally valid. And yeah, I don't stream anywhere else but YouTube at this point. So, but that's pretty much what I have to show today. So there's a lot of options in terms of what you could do with Raspberry Pis. They're a lot more powerful, especially with the GPU and everything else like that, that you can actually do to be able to get a lot of work done with them without having to use a lot of power or having to put a lot of expenditure into other kinds of hardware dedicated devices. So cool. So thanks for watching the video today, or the stream today. If you like it, be sure to hit that like button and leave a comment down below. If you know anybody who would like this kind of content, be sure to share it with them. I would appreciate it, and I hope they would appreciate it too. And if you haven't subscribed, please subscribe. It helps me out a lot with the YouTube algorithm, and then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.